Hey guys, welcome back to TheMindOfBrandon. As indicated by the title of this video, I'm challenging the flat earthers to provide actual evidence that the earth is flat. So a few weeks ago, I started watching another one of those flat earther videos while trying to come up with an idea for my own video. And I noticed early on in this video, the flat earther was actually saying something that I agreed with. You know, it's kind of showing some Bible passages that, you know, kind of put forward this idea that the earth is flat. And, you know, that's a point that I've made, is that the people who wrote the Bible were, in fact, flat earthers. But whereas flat earthers will tend to point that out to give credit to the idea that the earth is flat, I point that out to discredit the idea that everything in the Bible is 100% true. Because if the Bible's putting forward this idea that the earth is flat, then obviously it can't be 100% true, right? Well, that's logic that's not going to work on a flat earther. The next thing I saw in this flat earther's video was a world map resembling a flat earth map that contained a whole bunch of extra continents beyond the ice wall of Antarctica. The flat earther claims that this is a 1,000-year-old map originating from a Japanese Buddhist temple. So I went ahead and left a comment saying, a 1,000-year-old map that shows America, I call bullshit. That map is not 1,000 years old. Then this other guy came along and said,
I call BS on your face. Looking like a Hindu Muppet, laughing my fucking ass off.
A Hindu Muppet? What the fuck? What? Alright, notice how instead of trying to make a case for this being a 1,000-year-old map, he just attacks my physical appearance. Yep. So I told him, wow, you just proved the flat earth with that comment. Oh wait, no you didn't. So he tells me,
okay, then hit me with your best debunk of flat earth.
So instead of even attempting to make any kind of case whatsoever for the flat earth, he switches the goalposts and he challenges me to debunk the flat earth. Okay, totally fine with that. So I directed him to my video, The Flat Earth Fearer, and in response, I got hit with a barrage of different comments from this guy, not only on the initial video where I met this guy, but also on a couple of my own videos. So I'm going to be spending the duration of the rest of this video responding to this guy's barrage of comments.
Riddle me this. The moon, orbiting Earth while it travels at 66,600 miles per hour, reaches the backside of Earth. Now in order to get back in front of the Earth, it would now have to move much faster than the Earth to gain its new moon.
So I'm getting the impression that this guy is baffled by a speed comparison of, you know, how fast is the Earth going around the sun versus how fast is the moon going around the Earth, right? So, you know, you look that up, and basically it comes down to, well, the Earth is traveling at roughly 67,000 miles an hour as it orbits the sun, whereas the moon is traveling at roughly only 2,300 miles an hour as it orbits the Earth. And so this guy seems to kind of be in the context of thought of, well, wait a minute. How is the moon, which is significantly slower than the Earth, how that's supposed to get around the Earth if the Earth is going faster than the moon is? Now, someone already left a pretty good response to this down in the comment section, but I got the impression that the flat earther kind of missed the point, so I will now attempt to clarify the situation. Imagine for a moment that you're on the back of a long bus that's driving down the freeway at 60 miles an hour, which of course is way too fast for someone outside to catch up with on foot. Now, let's say that someone in the back drops a fart, and you decide to relocate to the front of the bus. So if the bus is driving at 60 miles an hour, how much faster than the midsection of the bus do you have to travel in order to get from the back end of the bus to the front? Now, I don't really expect you to do any math here. The point is that even if the bus is moving at 60 miles an hour, it's totally possible for someone that is actually on the bus to walk from the back to the front. You don't even need to speed walk to do it. This is because the bus is carrying its occupants just as the Earth's gravitational field carries the Moon. So relativity is an important factor. Are we positioned relative to space within the bus or relative to space outside the bus? Is the Moon positioned relative to space within Earth's gravitational field, or is it positioned relative to space beyond Earth's gravitational field? If the Moon existed outside of the Earth's gravitational field and orbited the Sun at 2,300 miles an hour, then the Earth, orbiting the Sun at 67,000 miles an hour, would whiz right past the Moon without any hope of the Moon catching up to the Earth. But since the Moon occupies space within the Earth's gravitational field, Earth's gravity is capable of carrying the Moon around the Sun at 67,000 miles an hour, while the Moon goes around the Earth at only 2,300 miles an hour.
It was great to watch you demonstrate static electricity as a pulling force, as that very action, along with electromagnetism, are proven while gravity remains to exist only in theory or convenient explanation.
Well, if that's your attitude, then it sounds like you're not even acquainted with the most up-to-date scientific understanding of what gravity is, which of course we get from Albert Einstein. He understood gravity as the curvature that is done into space by an object of mass. Now, to be fair, when it was first explained to me in that way, I was a little bit confused, because, I wasn't used to thinking of gravity as the curvature of space. I was used to thinking of it as a force that pulled things down to the Earth, right? But that's not what Einstein taught. Here we have a couple of M&Ms that are occupying space within my solid wooden floor, and here we have a big fat wooden Buddha being placed right between them. Notice that there's no obvious force attracting the M&Ms any closer to the Buddha though. No obvious gravitational field, there's no obvious electromagnetic field that is attracting the M&Ms any closer to the Buddha. But what if we modify the conditions of the experiment? What if we put these objects on a different kind of space? Here the M&Ms are occupying a thinner, lighter, more flexible space in the form of white Christmas tissue paper, which is suspended by several stacks of books, so there is some space underneath this tissue paper through which objects can move, a space that can be occupied by matter. And here we have again the big fat wooden Buddha being placed between the M&Ms. Hey, look at that. They just gravitated toward the big fat wooden Buddha. So my question to you is, was it the Buddha's electromagnetism that attracted the M&Ms to it, or was it the mass of the Buddha weighing down on the space that the M&Ms occupied, causing curvature within that space, or in other words, a gravitational field? Is that what caused the M&Ms to fall toward the Buddha? Now, everyone watching this knows it was not the Buddha's electromagnetism that pulled the M&Ms in toward the Buddha. The Buddha caused curvature to the space that the M&Ms occupied. That caused the M&Ms to fall toward the Buddha. They fell toward the Buddha because of the gravitational field generated by the weight of the Buddha's mass. So don't tell me gravity is just a theory. I just demonstrated it to you. I just showed you the generation of a gravitational field. Now I know some of you are thinking, well, wait a minute. Part of the reason that Buddha is weighing down on that piece of paper is because of the Earth's gravity. It's the Earth's gravitational field that's causing the Buddha to fall toward the Earth. And that is correct. So, even if you don't subscribe to Einstein's understanding of gravity, if you don't believe that massive objects can curve the vacuum of space, causing other objects to fall toward them, you have to admit, stuff still falls to the Earth. If you don't subscribe to Einstein's understanding of gravity, then you're left with some other understanding of gravity.
is called gravity.
Now, if you're a flat earther who doesn't believe in gravity, you might say, oh, it's electromagnetism that's pulling the Buddha down, right? I have a magnet right here, okay? And look, it sticks to this knife, right? Sticks to the knife just fine. What about to the Buddha? No, not a particularly magnetically attractive object there. No. We have evidence that electromagnetism is not what's pulling this down.
Lunar eclipse? Come on, man. Earth is a few times bigger than the moon. Its shadow would engulf it if that were the case. Think logically, Muppet baby.
Okay, the Earth's shadow does engulf the moon during a lunar eclipse. That's why it's called an eclipse. You see the Earth's curved shadow gradually move across the moon until it engulfs it. You're telling me to think logically?
You could not prove axial rotation, nor the source of gravity or its components. Only effects that could be attributed to magnetism in an electric universe.
Well, I already talked about gravity versus electromagnetism, but I did neglect to discuss the Earth rotating on its axis. And it's kind of ironic that you bring this up so close to the winter solstice and the changing season, which of course, are indications of the Earth rotating on its axis. Here in my neck of the woods, we of course recently had a winter solstice. On the other side of the world, they recently had the summer solstice. Emphasis on the other side of the world.
Galaxies do not abide by the laws of physics your videos claim, thus the invention of a new theory, an invisible dark matter tethering the vicious spin of galaxies, keeping them whole or together.
Well, if the laws of physics you're referring to are Newtonian physics, then it's certainly right to point out the shortcomings that Newtonian physics has. They work pretty well within their own domain, that is the domain of what could be considered to be normal space. Normal not necessarily meaning that it's more common. It's not more common throughout the universe, but it is the kind of space that we are used to. It's the kind of space that we exist in. And that kind of space really probably only makes up about 5% of the universe. 25% of the universe would be that dark matter that you mentioned. 70% would be dark energy. What's all this dark stuff? Well, what that basically means is we don't know what it is, okay? Actually, the planet Neptune, once upon a time, would have qualified as dark matter back when we were detecting its gravity, but we hadn't actually yet identified the source of that gravity. We hadn't seen the planet. But, we have, of course, since then discovered Neptune, obviously, right? And so, Newtonian physics works pretty well when, making predictions of, where is this planet going to be at what time, right? Works pretty well for that. You can use it to predict, here's where the planet's going to be, point your telescope there, and, the calculation winds up being pretty close to accurate. It's usually off by like a degree or two, maybe even 3, 4, or 5 degrees, something like that. It's usually off by a little bit, but it's close enough, right? And so this is why there's kind of been this attitude that Newtonian physics works pretty well within its own domain, okay? It works for most of the planets in our solar system. Why do I say most? Is there an exception? Yes! The planet Mercury, the planet closest to the Sun, because the space in the immediate proximity of the Sun is actually especially distorted by the immense gravity of the Sun. Okay, so Mercury doesn't exist in what we would consider to be normal space. Okay, and that's where Newtonian physics fails us, when it's that close to a major source of gravity, a source of gravity as massive as the Sun. And this is where Einsteinian physics comes in to save the day, because before Albert Einstein came along, we had a false dark matter explanation for what was going on with Mercury's orbit, why is it so weird. And so we had this hypothetical planet that we dreamed up called Vulcan, right? And so people were claiming this planet Vulcan for, you know, being an extra source of gravity that's affecting the orbit of Mercury, right? Well, turns out that Vulcan doesn't exist, right? Right. You know, Einstein comes along with his theory of general relativity, talking about space as a sort of fabric. It's made out of this stuff that can be distorted, you know, bent, folded, curved, right? And you know, so that's where we get this idea that gravity is the curvature of space-time. And when we're dealing with an object that's such a massive source of gravity, like the sun, then space in its immediate proximity is going to be more distorted than it would be in more distant portions of the solar system.
It is convenient to invent forces when an answer would threaten physics as they stand. So the logic is, let's not reassess our belief, let's invent 80% of the substance of the universe.
Let's not reassess our beliefs? Look who's talking! You're the one that's reverting back to the Earth is flat! I mean, come on, man. We let go of Isaac Newton's teachings where they weren't working for us, and we accepted Einstein into the fold. Right? Evolution, Big Bang, the Earth is round. Scientists have constantly been reassessing beliefs. This is why they don't promote making sacrifices to the gods. Just pray and everything will be alright. This is why we're moving past the ancient folk ways of doing things. Are we coming up with hypothetical dark matter and dark matter particles that may or may not exist? Sure, and you know, that certainly didn't work out too well with the planet Vulcan, but it did work pretty well with the planet Neptune. Gotta keep that in mind. Let's say it turns out that all of this hypothetical dark matter, all these dark matter particles, let's just say it turns out that none of that exists. We're wrong about all of it. Does that somehow invalidate all the evidence for a round Earth? Does that somehow provide evidence that the Earth is flat? No! No, it fucking doesn't!
Try holding a feather beside the largest building in your town and see if the mass of the larger object draws it in.
Well, I predict that this experiment would have about the same results as when I set the fat wooden Buddha down on the solid wooden floor next to the M&Ms, and the M&Ms were not attracted to the mass of the Buddha. We had to alter the conditions of the experiments. We had to change the space that we place these objects in. So yeah, I think that this feather experiment would go down about like when we had these objects on the solid wooden floor. But the only way to know for sure is to actually do the experiment. And that went pretty much like predicted. Just as the M&Ms were not attracted to the Buddha when it was sitting on the solid wooden floor, the feather was not attracted to the building that was sitting on the solid earth, which of course is the source of gravity that both the Buddha and the feather fell toward.
Pictures of the Earth from space? Smeh! You're indeed far gone. You seem to have a bit of sense. Have you spent 1 minute researching the photographs of Earth from space? Have you questioned any of the moon missions?
Well, let me put it this way. When we compare the claim that we've actually been to the moon versus the claim that the moon missions were faked, right? It seems more likely to me that we would have actually been to the moon. You know, when you consider the present state of science and technology, the fact that when you look up at the moon, it's right there. You can like look up and see detail on the surface of the moon. That's how close it is, right? It's not one of those distant, you know, twinkling stars or whatever. No, it's right there, right? So, given the present state of science and technology, it'd be downright odd if we haven't been to the moon by now. And, you know, I would say that if someone's saying that the moon missions were faked, that NASA hoaxed the whole thing, well, NASA is innocent until proven guilty. I'd say that's a pretty extraordinary claim, and extraordinary claims require extraordinary evidence. So if you're saying that NASA faked that, you got to make a compelling case that NASA faked it.
Have you wondered why gravity has been a dominant factor in science for over 350 years with no proof of existence, origin, or makeup? Theoretic science is what you are left with. A black hole, dark matter, etc. only exist in theory, gravity included. Such an ever-present force should be as easy to find, held to hatness as electricity, yet it hasn't because it is bunk.
Well, that was not entirely coherent, but he seems to be coming back to some things that we've already discussed, and we already discussed evidence for gravity and what that is more specifically. He's of course bringing up dark matter again. We talked about that. So yeah, he seems to be kind of hung up on some things that he doesn't seem to really understand.
How did the Apollo astronauts escape low Earth orbit and travel through the radiation of the Van Allen belts?
Well, my understanding is that they did it with a strategically timed and strategically navigated, well-armored high-velocity rocket. Basically, there are patches within this belt that are more heavily radiated than other parts, so that does allow for the possibility to navigate around the more heavily radiated parts. They're still technically being exposed to radiation, but not for very long, since it is a high-velocity rocket. And of course, it is well armored against this radiation. So while they were exposed to radiation, and it was enough to give them, they did have some symptoms of this exposure, like there's visual symptoms. They have like flashes in their eyes or something like that. But if I understand correctly, no one's skin started burning, no one got sick to their stomach. So they were exposed to radiation, but it was, an amount that was considered acceptable considering what they were trying to do. They're trying to get to the moon. That requires you navigate a course through this radiation belt.
Your example of static electricity as a pulling force did in no way explain gravity, yet it did prove how other forces such as electromagnetism that are detectable and understood can be accountable for the pulling of particles and all matter.
He's, of course, talking about the demonstration where I rubbed the balloon against my shirt to generate static electricity and then use the Trident wrapper stuck to the bottom of the balloon, right? And, of course, I wasn't doing that demonstration to explain gravity. What I was doing is showing that it is possible for something to stick to the underside because, I was responding to this idea, well, if the Earth is round, then people on the other side of the Earth are going to fall down. Later, when I started actually explaining some of the evidence for gravity, I talked about how we used Neptune's gravity to find planet Neptune. We found Neptune's gravity before we found planet Neptune because it was having gravitational effects on the planet Uranus.
What is the makeup of gravity?
Gravity is understood to be made up of these teeny tiny little particles that we call gravitons, right? Now, particles, of course, more technically, are really little waves of energy, right? You gotta keep in mind that at every single little point in space, there's an underlying fundamental field of energy. The various elementary particles, the forces, those are all just different manifestations of this underlying energy that is in every point of space. Finally, he posts a couple links to a couple of different videos showing a rare type of lunar eclipse that he wants me to explain. It's confusing to him because a lunar eclipse is supposed to be when the Earth comes between the Sun and the Moon, and the Earth's shadow engulfs the Moon. Yet, in these videos, the Sun and Moon are both visible in the sky, the Sun appears to be rising up over Earth's eastern horizon, and the Moon appears to be setting over Earth's western horizon. So, you'd expect Earth's shadow to be moving across the Moon from bottom up, but during this rare event, known as a selenium, the Earth's shadow is actually moving across the Moon from top to bottom. So, what the hell is going on here? Well, the guy in one of the linked videos actually tries to explain it.
Across the Moon, even though the Sun's coming up over here, and that must be because of the Moon's rotation around the Earth. It's moving farther up, even though the Sun's light is actually coming from over there. It's actually coming underneath the Earth. So if you imagine, the Sun is here, the Earth is here, and the Moon is back here, and this light was coming under the Earth, but the Moon must be rotating around even though we're turning, so it looks like the Moon is going down. It's kind of an optical illusion. It's pretty cool.
Don't get me wrong, that explanation really doesn't go far enough into the details, so I'll go ahead and clarify what's actually going on here. Basically, the Sun and Moon are not actually where they appear to be. This is due to the effects of atmospheric light refraction.
Now this is very interesting. You get to see the sunrise before the sun actually rises. You know what happens? Earth's atmosphere has different layers. And also, the optical densities of these layers decreases as you move away from the Earth's surface. That is with increasing height. So, what happens is, just before sunrise, before the sun reaches the horizon, the sunlight enters obliquely into the atmosphere. It gets refracted through the atmospheric layers. Now this refraction causes the light rays to bend. So the sunlight actually reaches the Earth's surface in a curved path. Now, what happens from the point of view of an observer? Following the path of the light rays entering the eyes, the observer actually sees the sun slightly above its actual position.
Now what I've got here, this is a light box, so it's basically a box with a slit, so a single beam of light can come out here, and the light is entering this plastic rectangle here, and what's happening is the light, as it enters, it's forced to slow down, and because it's forced to slow down, it will bend towards the normal, and then as it leaves out here, it actually runs parallel with the light that enters, but it's actually been shifted up. And if I lift the block up, you should see, you can see it's moving. But this is what's happening here. The beam is going in here, it's being bent towards the normal, moving up here, then as the beam of light exits the block, the effect is reversed, and the beam continues in the same direction.
So during the selenium, just as the sun appears to be coming over the horizon when it's actually below it, the moon appears to be over the horizon after it's already descended below it. So you might need to keep in mind that at sunrise, the sun is not actually literally rising up above the Earth's horizon. The sun does not actually come up and then go down. It just looks that way because, of course, the Earth is rotating on its axis. The moon, on the other hand, actually is going around the Earth. So I'm hoping that everyone noticed that at no point in any of that flat earther's comments did he even attempt to make any kind of case whatsoever for a flat Earth. He seemed mainly just to be denying science and making arguments from ignorance. Do let me know if you notice that down in the comment section below. Make sure you give this video a thumbs up and share it with other people. Go ahead and subscribe to this channel if you haven't already. And here is an outtake for you guys. What's so funny? It's funny how long you've been there. It's funny turn on the camera and see your mug there. It's like the noisiest door ever. Yeah, there should be some WD-40 around. Something. I should make it easier to sneak up on him. You should. Are you recording? It is recording. This is an outtake. Oh yeah? So whip it out. The camera. Holy shit, your eye's red. Yeah, it's been that way for a while. Alright. Flat earthers. Say hello to my little friend. Oh, yeah. Ooh. Your virginal butthole is so tight, flat earther. Mmm. Yeah. Ooh. Mmm. God. That was fast. I give you credit, flat earther. Wow.
The Earth isn't flat.